Dear students, I welcome you for Standard 8 General Science subject. We are going to learn about sound and this is the first module. Children, this chapter focuses on making you understand about what is sound, how sound is produced, what are the ways a sound propagates and the medium for its travel, what is meant by frequency of sound waves, what is the relationship between sound and music, how sound is produced by human, and you will also be learning about sound generation by loudspeaker. In this module, children, we will be learning about production of sound, propagation and traveling of sound, about bell jar experiment, and also about the frequency of sound waves. Shall we start? The very basic question is, what is meant by sound? Sound, as you see, is a pressure wave. It is created by a vibrating object. How a sound is produced? When an object vibrates, sound is produced. Let us see the production of sound in something called a tuning fork. A tuning fork is made up of two prongs. These two are prongs and a stem. Keeping the stem steady, if the prongs are struck, they will start vibrating. As you can see, the stem is here deep inside, stuck deep inside, and the prongs are struck and you can clearly see the vibration. So this is how sound is produced in a tuning fork. Children, you have seen the movement of the tuning fork. The prongs of the tuning fork are set into periodic motion in forward and backward direction. Observe this, children. If during the vibration, the prongs of the tuning fork go away from each other, the air outside is compressed. It's been pushed. So, the pressure near the prongs will increase. Then, in this state, there is high pressure created in this region A. It is marked as A. In this region, a high pressure is created because of the movement of the prong. It pushes the air near it. So, this region in which the air is at high pressure and high density is called as compression. You know the meaning of the word compression. The air is compressed now. So, take this one, third picture. If the prongs of the fork come close to each other, so what happens? The air molecules near the prong, they have so much space to move. So, they move away from each other. In this stage, the air pressure in this region, that is in the region A, decreases. You can see that in the picture. So, such a region where air density is low is called as rarefaction. Children, in this picture, you can see compression, rarefaction, and this is a normal stage when the air is not disturbed at all, like the initial stage. So, when the prongs move away, they create compression, and when the prongs move towards each other, they create rarefaction. So, when the compressed air molecules transfer their energy to the air molecules in the next region, this is what you are seeing. Initially, the portion A is under compression. After the forks, the tuning forks prongs move closer, what happens? This energy in level A is being transferred to B, and then after compression, the rarefaction occurs. So what happens now, children? The air in the next stage goes to compression. Now can you guess how the energy gets transferred? Such periodic motion of the prong creates compression and rarefaction, and these will propagate, that is move away from the prongs. This is nothing but a sound waves. Now children, do you understand how sound waves are created? So here is the picture that is depicting the periodic motion of the prongs, and you can see the colors which are bright and lighter. Brighter denotes compression, lighter denotes rarefaction, and how they are getting moved away from the prong. This is how sound is produced. When the produced waves reach our ear, the eardrum also vibrates. So accordingly, the specific signals reach the brain and we get a sense of hearing a sound. This, children, occurs almost immediately. Whenever there is a creation of sound, you hear it immediately because the speed with which sound travels is very fast. Children, use your brain power here. If sound waves are generated in air, what moves away from the source? Is it the air itself or the state of compression and rarefaction created in the air? Think over it. See, if the source of a sound is vibrating, it bumps into the nearby air molecules. So these air molecules will bump to its neighbors and it keeps on going so forth. So the result is a wave of vibration traveling through the air to the eardrum. So what is traveling? The vibration alone is traveling to the eardrum, which in turn also vibrates. So this is the eardrum, children. You can see these are set of bones, very sensitive bones. So according to the pressure in the eardrum, they move accordingly, and this is the signal sent to the brain, and our brain perceives the sound we hear. Let us learn how sound propagates. Sound travels through some medium like solid, liquid or gas, and it reaches us. So if you see, if there is no medium, can we hear the sound? What do you think? No. Without a medium, we cannot hear a sound. So this picture you can understand. This is the solid medium, this is liquid, and this is a gaseous medium. You can see sound travels faster in the solid medium, then somewhat less faster in liquid, and comparatively it is lower in gas medium. But are you astonished, children? Because even in the gas medium, we almost hear the sound immediately. But naturally, in the solid medium only, we will be hearing the sound faster than gases and liquid. Children, we are now going to learn about the propagation of sound in a medium through an experiment called bell jar experiment. You can see the experimental setup here. In this experiment, a vacuum-tight bell jar is placed on a smooth and horizontal surface. You can see it placed in a smooth and horizontal surface. The bell jar is connected to a vacuum pump. You can see it is getting connected to a vacuum pump via a tube. So we can remove the air inside this bell jar. We know that there will be air inside the bell jar. So using the vacuum pump, we can remove the air inside it. You can see the bell jar contains an electric bell which is connected to the power supply through the lid of the bell jar. When you begin the experiment, the vacuum pump is off and the bell jar will contain air inside. So if the key to the electric bell, if you switch on, you will hear this bell starting ringing, and the ringing can be heard outside the bell jar. Then after that, what we will do, we will switch on the vacuum pump and start removing the air totally from the bell jar. As the quantity of air, the amount of air keep decreasing, the level of ringing sound also will decrease. So if the pump is operated for a long time, that is almost the air inside everything is removed out, we will not hear anything even though we can see the bell ringing. So children, from this experiment, we understand that sound needs a medium to propagate. Children, always remember this. Imagine two astronauts are on a moon talking to each other directly. So even if they are very close to each other, The moon, children, does not have an atmosphere, means that there is no air in the moon. So since there is no medium necessary for generating as well as propagation of sound, they cannot hear the sound between them. That is, they cannot hear anything between them, since there is no medium that can help the sound to travel and reach the other person's ears. So the astronauts use some technology like we are using cell phones to communicate with each other. So the waves in the cell phone, they do not need any medium for propagation. So you have to remember that when we are there in the moon, we cannot speak to each other directly because of absence of atmosphere, that because of absence of any medium for propagation of sound. So children, now you have understood how sound is produced and how sound propagates. Now let us learn about frequency of sound waves. What is meant by that? If any object vibrates in the air, so such sound waves are produced in the air. This we are aware now. Imagine this, take this picture. So there is vibration produced in the air. You can clearly see the compression of air molecules, rarefaction. You can see alternate compression and rarefaction. We understand that sound propagates in air. Above that, it is represented in a wave form. Children, assume this dotted line is a straight line. The compression and rarefaction are denoted as follows. If there is increased pressure, we call it as compression. So it will be a upward curve above the normal straight line. And to represent rarefaction, we just bring the line below it. It means that there is reduced pressure in the air molecule. So instead of making a diagram and representing the molecules, how they are compressed and how they reduce in pressure, we just easily denote them in the form of waves. The upward curve denotes a compression and the downward curve denotes a rarefaction. Using this, come let us learn about the frequency of sound waves. Talking about the frequency of sound, children, one compression and one rarefaction together form one cycle of wave. If I say one cycle, it is a combination of one compression and one rarefaction together. So it makes one cycle. So the number of cycles formed in the air in 1 second will be decided by the number of times the body vibrates back and forth. That is, the number of times, for example, our tuning fork vibrates in 1 second. So according to the vibration, the cycle is formed. Here you can compare two types of waves. One is happening very fast. So we can say the frequency is high. There is so much number of waves in 1 second. So it is termed as a high frequency. Whereas in other type of sound waves, it is very less number. So we can term it as low frequency. So we understand that the number of cycles that are produced in air or any other medium, not only air, whether it is solid, liquid or in gases, the number of cycles produced per second is called frequency of that particular sound wave. The frequency is measured in hertz. That is, the unit of frequency is hertz. If one cycle is completed in 1 second, so a sound wave takes 1 second to complete one cycle, then it is said to be 1 hertz. Children, look closely at these two waves. So the red color dot is the wave that is moving per second. If you see the first one, the wave moves slower. So the distance between one peak and the other peak is higher. So we call this as wavelength. So the first picture is having a long wavelength and the frequency is also less. Observe the second one, the red dot moves faster. the time between first and second peak is very less. So it is having very short wavelength and the frequency of this wave is higher. So this is of low frequency, this wave is of high frequency. Are you clear about frequency, children? Let us see the frequency of sound in our tuning fork. The tuning fork shows its frequency to be 512 Hz. What does it mean, children? Yes, you are right. The tuning fork vibrates about 512 times per second. So we say that the tuning fork is having the frequency of 512. So these vibrations will set 512 cycles of compression and rarefaction per second. Very fast, isn't it? That is why, children, we say the sound generated by the fork will have a frequency of 512 Hz. So the frequency of tuning fork depend upon the dimension, that is the length and thickness of the prong and the material with which the prong is made, all decides the frequency of the sound produced as well. So we have learned a lot of information, children. Let us summarize our points. When an object vibrates, sound is produced. The region in which air is at high pressure and high density is called as compression. The region in which air is at low pressure and low density is called rarefaction. When the sound waves reach our ear, the eardrum vibrates. So accordingly, specific signals reach the brain and we get a sense of hearing a sound. Sound generation and propagation needs a medium for travel, say for example air. This was proved using our bell jar experiment. As there is no medium in moon for generation and propagation of sound, the direct communication between astronauts is not possible. One compression and one rarefaction together forms one cycle of the wave. Number of such cycles that are produced in the air or any other medium per second is called as the frequency of the sound wave. The frequency is measured in hertz. So children, thank you for listening patiently. We'll be learning more interesting fact about sound in the coming module.